Hey everyone, welcome to today's explainer. Today we're taking a magnifying glass to this science that literally powers our daily lives. We're going to decode the everyday magic of chemical changes. I'm talking about the invisible stuff happening around you, inside of you, and honestly for you every single second of the day.
So to get us started, I want you to picture something we've all probably done. Imagine you're in the kitchen, right? You're baking a cake. You take your flour, sugar, eggs, and butter, and you toss them in the oven. And boom, what comes out is this fluffy, delicious cake. But here's the big question. Is that transformation a physical change, or is it a chemical change? This whole cake analogy is actually the perfect starting point for our explainer today because it sets up the fundamental rules of how matter transforms. Once we get these rules down, what just looks like everyday kitchen magic suddenly reveals itself as this incredible, highly structured science.
Okay, let's dive into this. Here's our roadmap to this everyday magic. First, spotting a chemical change. Second, mixing and heating up. Third, nature's triggers, light and oxygen. Fourth, shocking changes with electricity. And finally, number 5, chemistry in everyday life. Let's hit the road.
All right, first stop on our roadmap, Section 1, Spotting a Chemical Change.
So the crucial point here is understanding the difference. A physical change? Well, that means no new substances are actually formed. Think of an ice cube melting into water. You can just pop it back in the freezer, meaning it's totally reversible. You can even separate things out using physical changes, like filtering or evaporating. But a chemical change? Now that's our baked cake. Entirely new substances are formed with completely changed properties. I mean, you can't exactly unbake a cake, right? So it's irreversible. Plus, in some of these chemical reactions, energy, like heat or light, is actually produced in the process.
Moving right along to Section 2, Mixing and Heating Up.
And this brilliantly illustrates what happens when we intentionally force things to change. When he combines certain reactants or turn up the temperature, we create entirely new, irreversible substances. For instance, just mixing an acid with a metal gives us a salt plus hydrogen. On the flip side, when we use heating as our trigger, we get what's called thermal decomposition. A great example, if you blast calcium carbonate with heat, it actually breaks down into calcium oxide and carbon dioxide. We're literally forcing the chemical bonds to break and reform into something brand new. Let's anchor this heating trigger to some super tangible examples you see all the time. Think about cooking. Heating kicks off essential chemical reactions like the caramelization of sugar. It completely transforms the flavor profile of your food. A real game changer for dessert. Another prime example of heating is combustion. That's when a substance combines with oxygen in the presence of heat. We use combustion every single day, when petrol burns, releasing heat energy to power our cars. Though, it is definitely worth asking ourselves about the long-term environmental impacts of all that combustion for sure.
Now let's step out of the kitchen and into the wild, with Section 3, Nature's Triggers, Light and Oxygen.
So it turns out light acts as an incredibly powerful catalyst. The most obvious example here is photosynthesis, where plants take in carbon dioxide and water and literally use sunlight to form glucose and oxygen. I mean, it's absolutely crucial for maintaining our atmosphere. But photochemical reactions aren't just for plants. In technology, like traditional X-rays and photographic films, light causes a chemical called silver bromide to decompose. It breaks down into silver and bromine. So light is quite literally drawing the picture chemically. How cool is that?
Then we have interactions with oxygen, which we call oxidation. This is exactly why understanding these triggers really matters. Inside our own bodies, oxygen breaks down glucose during aerobic respiration, giving us carbon dioxide, water, and most importantly, vital energy. But out in the real world, when oxygen and moisture mix with iron, it creates hydrated iron 3 oxide. Actually, scratch that fancy term. You probably know it simply as rust. In tropical, super humid climates like Singapore, this rusting is a constant, persistent chemical change. Knowing the chemistry behind it helps us find real preventative solutions, like painting or oiling the iron so it doesn't degrade.
All right, let's turn up the juice. Section 4, shocking changes with electricity. The main process we're looking at here is called electroplating. Basically, by definition, electroplating is coating an object with a metal by passing an electric current right through a solution. This is how we manipulate matter down at the atomic level, using actual electricity to force a metal layer onto another surface.
Now, what's really interesting about this process is exactly how the electrochemical transfer works. A battery pushes an electric current through a circuit. Then, immersed down in the solution, a solid piece of gold reacts as that current flows through it.
This causes tiny gold particles to literally migrate across the solution and attach permanently to a silver core. It's kind of like a microscopic magnet effect.
Let's break this complex process down into a simple 3-step recipe that's super easy to remember. Step 1, submerge your core object into a solution filled with particles of the metal you want to use. Step 2, pass an electric current through the circuit. And step 3, let the electrochemical process do the heavy lifting. The metal particles permanently coat the core object. You're basically painting with electricity and chemistry.
And hey, this isn't just for making cheap trophies look shiny. The real-world applications are absolutely vital. For aesthetics, think of Singapore's famous rhesus gold orchids. Pioneered way back in 1976, this process takes a beautiful, natural orchid and encapsulates it in real gold. Over in technology, the computer circuits and cell phones we use every single day rely on incredibly thin coatings of gold and silver. It increases electrical conductivity without totally breaking the bank. And in the medical field, implanted joints, screws, and surgical tools like forceps are all electroplated to make them completely corrosion-resistant and compatible with sterilization.
Let's move on and see how this all builds together in our grand finale. Section 5, Chemistry in Everyday Life. Just take a look at this 12-point list of chemical reactions happening around you all the time. Ready? Combustion, powering your car. Photosynthesis, giving us air to breathe. Respiration, keeping your very cells alive. Anaerobic fermentation, oxidation, rusting fences. Electrochemistry, powering your device's batteries. The digestion of your breakfast. Acid-base reactions, the cooking of your dinner. The spectacular explosion of fireworks. The rotting of that forgotten food in the back of your fridge. And the electroplating protecting vital tools. I mean, wow, this list really shows the sheer scale and omnipresence of chemical reactions in just your daily routine.
Which brings us to the end of our explainer today. But before we wrap up, I want to leave you with a thought-provoking question. Think about all those processes we just discussed. What would our world look like if these irreversible changes suddenly stopped happening? Honestly, without chemical changes, there'd be no energy, no growth, no cooking, and literally no life as we know it. I really hope you walk away from this explainer with a newfound appreciation for the foundational chemistry surrounding you, and maybe a real hunger to spot this everyday magic happening right in front of your eyes. Keep learning, and I'll catch you next time.